AI in a box. What if I were to tell you that you can actually own a supercomputer? The same one that was used in 2016 to start developing OpenAI's ChatGPT. Amazing, right? Well, Jensen Huang, CEO of Nvidia, just showcased this supercomputer at CES 2025. And in this video, we're going to talk about AI in a box, Agentic AI, and all the other amazing things that Nvidia are doing in the world of AI. Let's get to it. Nvidia is arguably one of the most important company in the world of AI and in the age of AI that we're living in right now. I believe that without Nvidia, frankly, we wouldn't have the technology that we're having right now, because many of these companies rely on Nvidia's chip and their GPUs for processing powers for all of these large language models. So I want to share with you this brief introduction video from CES 2025. Jensen Huang showcased all of the things that Nvidia are doing with their partners to help push our life forward with AI. Let's have a look.
This is how intelligence is made. A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, the first step into an extraordinary world, where endless possibilities are born. Tokens transform words into knowledge and breathe life into images. They turn ideas into videos and help us safely navigate any environment. Tokens teach robots to move like the masters. Inspire new ways to celebrate our victories.
A martini, please.
Tony, light up.
Thank you, Adam.
And give us peace of mind when we need it most.
Hi, Maroka.
Hi, Anna. It's good to see you again.
Hi, Emma. We're gonna take your blood sample today, okay?
Don't worry. I'm gonna be here the whole time.
They bring meaning to numbers to help us better understand the world around us. Predict the dangers that surround us. And find cures for the threats within us. Tokens can bring our visions to life. And restore what we've lost.
Zachary, I got my voice back, buddy.
They help us move forward. One small step at a time. And one giant leap. Together. And here is where it all begins.
That was pretty much remarkable, right? Nvidia have their hands on pretty much all aspects of our life. They worked on autonomous driving with Tesla and other companies. They also work in healthcare, weather predictions, hurricane predictions, and also companion robots and robotic arms that can cook for us. Everything involves Nvidia. For business owners and entrepreneurs, what do we care about? We care about optimization, our workflow. We care about revenue growth. So what's better than AI agent to help us do that, right? 2022 was the first time that the world saw ChatGPT and knew what it can do. Then 2023 was the year that AI exploded. I remember about 300 to 400 tools that came out every single month. Everything on my Twitter feed was about a new tool with AI infused, AI powered. Then came 2024, all of a sudden everything settled down. Now, 2024, we saw a lot of video AI. We saw a lot of models, different LLM models that came out with the reasoning capability. And with that, people thought that 2024 was the year for agentic AI, for AI automation workflow. I believe that 2024 was just the beginning of AI agents and AI workflow, AI automations. The reason is because we just saw a glimpse of the reasoning models. Now in 2025, we are seeing the full flesh of AI that can reason, and companies are starting to embed those into their AI workflow and AI agents. And so I want to share with you in the next portion of this video Nvidia's own agentic workflow or agentic model. Let's have a look.
In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf. And so the way that you would bring these specialized agents these special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company, the business process is different, the way you work is different. So you would give them examples of what the work product should look like, and they would try to generate it, and you would give it feedback, and then you would evaluate them, so on and so forth. And so that, and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say. And we even give them access to certain information. Okay, so that entire pipeline, digital employee pipeline, is called NEMO. In a lot of ways, the IT department of every company is going to be the HR department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies to use. Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of. All of this is completely open source, and so you could take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the Nvidia Llama Nemotron language foundation models. Llama 3.1 is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not, basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. We're also working with the ecosystem. All of our NVIDIA AI technologies are integrated into the IT industry. We have great partners and really great work being done at ServiceNow, at SAP, at Siemens for industrial AI. Cadence is doing great work. Synopsys is doing great work. I'm really proud of the work that we do with Perplexity. As you know, they revolutionized search. Yeah, really fantastic stuff. Codium, every software engineer in the world. This is going to be the next giant AI application. Next giant AI service, period, is software coding. 30 million software engineers around the world. Everybody is going to have a software assistant helping them code. If not, obviously you're going to be way less productive and create less or good code. And so this is 30 million. There's 1 billion knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents.
AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's Agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at NVIDIA, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual Lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And video analytics AI agents, built on an NVIDIA Metropolis blueprint, including Nvidia Cosmos Nematron vision language models, Llama Nematron LLMs, and NeMo Retriever. Metropolis agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, they monitor processes and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here, for every organization.
Okay. That was the first pitch at a baseball game. That was not generated. I just felt that none of you were impressed. Okay, so AI was created in the cloud and for the cloud. AI is created in the cloud and for the cloud. And for enjoying AI on phones, of course, it's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect in the cloud. It was created in the cloud, is perfect in the cloud.
I know what you may be thinking. The people who are knowledge workers, people who works in corporate America, they are in danger. The reason is because, as you just saw, agentic AI workflows, when you apply agentic AI workflow like the one from Nvidia and you combine it with a model that can reason like ChatGPT 01, the agents become so powerful and they can perform tests. They can do better work than a lot of us. And the crazy thing is, they don't sleep, they don't need to eat, they don't take 6 days, they don't do anything. We work 40 hours a week. They can go 24/7, 365, so long as you have power and you have internet. So the writing is on the door for knowledge worker. People who are knowledge worker and corporate workers, they know it. It's coming. 2025 is the year of AI agents. I strongly believe it because we have the ingredients for it now. An AI agent doesn't just work for big corporates. It works for small business owners. It works for solopreneur like you and me. You might not think that you could use AI agent, but tasks like writing social media posts, managing your inbox, or chatting with your customer as a customer service rep, those are things that chatbot and your agent can handle very, very well for a small business. And then there are other things that you can design, you can have your agent perform for you as well. You might not be aware of it yet. And that's fine. A lot of this is new, and as we get familiar with how these things work and how reliable they are, then you will feel more comfortable of shifting more responsibility from you, the human, to machine. So that's on the knowledge worker side. The physical labor side, well, you're not safe either. AI is coming for you. AI is coming for you, unfortunately. It could be slower, but Nvidia is making it easier for AI to come for physical labor. To do any kind of AI or to train any kind of AI, you need data, a lot of data. That's why at the beginning, OpenAI were sued by many of these publications companies because they knew that OpenAI trained on their books, on their data. And they sue OpenAI because of copyright issue, whatever. So same things apply with the physical world, physical labor world. You need a lot of data, and it's not easy to collect real world data to train AI on. So I'm going to show you in the next part of this video coming up, NVIDIA's real world model. A model where it's using real world data to train the AI, and then that AI then can now create synthetic data to train the real world physical labor AI. This AI actually understands physics, it understands cause and effect. Let me show you NVIDIA's real world AI.
Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that, that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create we need a world foundation model. Today, we're announcing a very big thing. We're announcing Nvidia Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. Nvidia Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an Nvidia CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use Nvidia Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance. Even across multi-sensor views, Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer ecosystem, Nvidia is helping advance the next wave of physical AI.
Nvidia Cosmos. Nvidia Cosmos.
Now that you have seen Nvidia's Cosmos, how they actually create synthetic data to train physical AI, now let's take a look at the fun part. How people are actually using Cosmos in the real world, in the physical AI sort of robotic world.
With this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models. And so this is the Nvidia Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub. We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse, and the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of course, for robotics, for industrial applications, it is very, very clear. This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the DGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or in a stadium, or whatever it is. These computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. Instead of a three-body problem, we have a 3-computer solution. And so it's the NVIDIA robotics. So let me give you 3 examples. All right, so the first example is how we apply all of this to industrial digitalization. There are millions of factories, hundreds of thousands of warehouses. That's basically it's the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation in the future. And all of it will be infused with robotics. Well, we're partnering with Kion, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have through the developers and ecosystem partners. And we have just a growing number of ecosystem partners connecting to Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. So let's take a look at that. This one example that we're doing with Kion and Accenture.
Kion, the supply chain solution company, Accenture, a global leader in professional services, and Nvidia are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an Nvidia Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Kion can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with Nvidia, Kion and Accenture are reinventing industrial autonomy.
So that's how Nvidia is using physical AI to tackle automations and robotic in the manufacturing and warehouse industries. Like you heard Jensen Huang said, it's a 50 trillion with a T, dollars, $50 trillion manufacturing industry. And they're using their system to train our robotic, to create synthetic data, and then use that data to then train large language model. It's just fascinating the things that they are doing right now at Nvidia. Now, for a small business owner and entrepreneur, how does this really apply to you? Just like ChatGPT when they first came out, if you wanted to use the API, it was really expensive. Even before ChatGPT came out, Jasper AI was really expensive. It was using GPT-3. And then eventually, when they have more computing power, they have more training, it's cheaper and cheaper to use their API. Now take that and turn it to the physical AI world, right? Right now, maybe it's still early, it's expensive, but eventually, if you have a small warehouse and you're doing e-commerce, well, maybe you can have some of these robots that's working for you autonomously. Just imagine that, right? In the industrial setting. Or like Tesla's Humanoid. This is a perfect time to segue over to the robotics section. This is a good part to transition over the robotic sections and showcase what this is a good time to transition over and talk about robotic. Tesla Humanoid, I believe, is going to be the next big thing for the consumer market. Elon Musk made Tesla really affordable for people to now have electric car and then eventually have full autonomy and then eventually have full automatic driving cars. And so I think it's going to be the same with the consumer humanoid market when they are able to use data like this, like what you just saw, to train consumer humanoid. Not just in the industrial market, but also for the consumer market. So let's have a look.
Humanoid robots. My friends, the ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100 plus years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. Nvidia Isaac GR00T helps tackle these challenges, providing humanoid robot developers with four things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The Nvidia Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large datasets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos, for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos multiverse simulation engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by Nvidia Isaac GR00T.
I am just so excited, so pumped up for the year 2025, just because of all of these AI-enabled technologies. You saw that they were able to train Humanoid with data synthetically generated by Nvidia's program, and then use Apple Vision Pro to start training it. You know, you no longer have to have the physical product for someone to actually go and perform the task. All you need is, you know, just like in that video, some data, and then you have Vision Pro, some augmented reality glasses, so you can start training your humanoid robots. So it's making it's easier for all of these companies to train their robots on different human tests. Let's transition to something that apply more to us, immediately to us, which is AI in a box. You're gonna hear Jensen Huang said that in 2016, he delivered this first supercomputer to Elon Musk, Sam Altman, and OpenAI. Now, all of these years later, now in 2025, we are now able to get our hands on that exact same computer, only much smaller and much better. It's an improved version of the supercomputer that started OpenAI. Imagine you're a law firm and you have clients' data. You have some sensitive information, some attorney-client privilege information. You know, I might be making this up, but you know, things that you might not want the world to know, no matter how secure they say it is, or you know, even though they say, yeah, we don't train on your data. Who knows? A while ago, OpenAI even said that they have no clue how ChatGPT version 4 work. In a white paper I read, they said that they only knew about 10 to 12% the capability of ChatGPT 4. So if they didn't know how a program works, how can you control it and know for sure it's not training on your data? And I say that to basically make a contrast and make a case for what I'm about to tell you here. With this mini supercomputer and AI in a box, you can essentially have your own AI locally, and you can use it to train on your own data. Maybe you have some court cases that you want to cite, or you have precedents, things that you have done at your own firm. You don't want anyone else to know about it. Now you can train it, and then you just give it to your junior associates. Before this, you have RAG, retrieval augmented generations. Let's say you dump all of your data into a database, and then your AI agent would go search for that relevant information in your database. So it's not fine-tuned, it's not really trained on your data. All it's doing is it's going to your database and finding the relevant information that it thinks is useful for your query, and then return that information to you. Whereas now with this local AI in a box machine, well, now you can just fine tune it right there, right in your office. So let's have a look.
None of this would be possible if not for this incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits. Well, before we launched it, I shrunk it to DGX, and to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company. And it really revolutionized, DGX1 really revolutionized, where's DGX1? DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and many of NVIDIA engineers were there, and we celebrated the arrival of DGX1, and obviously it revolutionized artificial intelligence and computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. You know, we want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX1 was smaller. And, you know, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA's software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or, connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside. It's just so cute. And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Gray CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company. And they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do. And it's just, I think I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those? And if you use PC, Mac, you know, anything, because you know, it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like. If you would like to have double digits, this is what it looks like. You know, and you connect it together with ConnectX, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits.
A tiny computer that allows us to run a 200 billion parameters LLM system right at our local office. Pretty amazing. Now, 200 billion parameter is about half of the latest open source model from Meta AI. It's about 405 billion parameters, and you know, Nvidia, this is half that. We're living in the best time of our life right now. Now, if you enjoyed this video, I would appreciate it a lot if you can like the video, subscribe to the channel, and then leave a comment. Tell me, what are you most excited about from CES 2025 or from Nvidia? Now, YouTube knows that you're gonna like the video coming up next, so they suggested it for you. Until next video, I'll see you in the comment section.